So let's talk about a shape you probably think you know inside and out, the parabola. I mean, we all remember y equals x squared from algebra, right? But it turns out there's a much more powerful and honestly more elegant way to understand what a parabola truly is. So let me just ask you straight up. You can probably graph y equals x squared in your sleep, but could you define what a parabola is without using an equation? Like, what's the fundamental property that makes it a parabola? That's the question we're going to dig into, and trust me, it's going to unlock a whole new way of looking at them. We're going to move past that basic formula and get into a really beautiful geometric definition. And it's this shift in perspective that lets us describe any parabola facing any direction anywhere on a graph. It's pretty cool. And here it is. This is the heart of it all. A parabola isn't just some U-shaped curve. It's what we call a locus of points. And every single point on that curve follows one simple rule. Its distance to a special point, called the focus, is the exact same as its distance to a special line, called the directrix. This right here is the golden rule. This simple idea of equality, this perfect balance between a point and a line, is basically the DNA of every single parabola in the universe. If you get this, everything else is going to click into place. So how do we turn that geometric idea into an actual equation we can use? Well, we get these two standard forms. Now look closely, because the difference is subtle but super important. For a vertical parabola, one that opens up or down, the x term is squared. For a horizontal one, opening left or right, the y term is squared. That's the very first thing you should always look for. Now, you probably noticed that little letter p in both of those equations. Well, p is the secret key to unlocking the whole thing. Its sign, positive or negative, tells you which way the parabola opens. If p is positive, it opens towards the positive side of the axis, so up or right. If p is negative, you guessed it, it opens towards the negative side, down or left. And the value of p itself? That's the actual distance from the vertex of the parabola out to the focus. Okay, that's enough theory for now. The absolute best way to really get this is to see it in action. So let's apply these formulas to a few classic problems. Don't worry, once you see the pattern, it's a really logical process. All right, first one up, y squared equals 12x. Okay, step one, which variable is squared? It's the y, right? So right away, we know this is a horizontal parabola. It opens sideways. That means we're using the y squared equals 4px form. Step two, let's find p. We just take the coefficient, that 12, and set it equal to 4p. So 4p equals 12, divide by 4, and you get p equals 3. Since p is positive, it opens to the right, so the focus is at p, 0, which is 3, 0. And the directrix is the line x equals negative p, which makes it x equals negative 3. See? Simple as that. Okay, let's try going the other way. This time, they tell us the vertex is at the origin, and the focus is at the point 0, negative 2. So think about it. The focus is below the vertex. That means this thing has to open downward. Since it opens down, our p-value has to be negative. And the distance from the vertex at 0, 0 to the focus at 0, negative 2 is just 2. So p equals negative 2. Now we just plug that into our vertical formula. X squared equals 4py. That gives us x squared equals 4 times negative 2 times y, which simplifies down to x squared equals negative 8y. Boom, done. All right, last example. And this one looks a little trickier because the vertex isn't at the origin. We've got x minus 2 squared equals 8 times y plus 1. First things first, let's pull the vertex hk right out of the equation. And here's the key. You have to flip the signs you see. So the vertex is at positive 2, negative 1. Next, find p. We set 4p equal to that 8, which means p equals 2. Because the x term is squared and p is positive, we know it opens up. Now we just calculate. The focus is at hk plus p, which is 2, negative 1 plus 2, or 2, 1. The directrix is at y equals k minus p, which is y equals negative 1 minus 2, giving us y equals negative 3. It just goes to show the same logic works perfectly even when the parabola is shifted around. Now, even though the process is pretty straightforward, there are a few common traps that are just so easy to fall into. I want to point them out right now so you can avoid them completely. Think of this as your little checklist before your next test. All right, here are the 3 big ones. Number 1, and this is the most common mistake by far. Don't confuse 4p with p. That number in the equation, like the 8 we just saw, that isn't p, it's 4p. You always have to divide it by 4 to find the real p. Second, getting the direction wrong when p is negative. Just remember this. Negative p means the parabola opens toward the negative side of the axis, either down or left. And finally, the most basic one. mixing up which one's vertical and which one's horizontal. Here's my little mental shortcut. Think about y equals x squared. You already know that one opens up, which is vertical. So x squared is always vertical. That just leaves y squared to be the horizontal one.
So you might be wondering, why do we even care so much about this focus and directrix stuff? Does it matter outside of a pre-calc class? The answer is a huge yes. This geometric property is actually the secret behind some of our most important technologies.
And here it is. This is the magic property. When parallel rays, like light from a far-off star or a signal from a satellite, hit the inside of a parabola-shaped reflector, something amazing happens. Every single ray, no matter where it hits, bounces directly to one single point, the focus. It is an unbelievably efficient way to gather and concentrate energy.
And once you know about this property, you start seeing it everywhere. It's how a satellite dish takes a weak signal from space and focuses it onto the receiver. It's how giant radio telescopes can listen for whispers from the cosmos. It even works backwards. In your car's headlight, the bright bulb is placed at the focus, and its light bounces off the reflector to create a powerful straight beam of light. It's a truly fundamental shape in modern engineering. So from now on, when you see a satellite dish or a flashlight, or even just the arc of water from a fountain, I want you to think about that invisible point and that invisible line, the focus and the directrix, that are secretly defining that perfect curve. So let me leave you with this. What else out there in your world is being shaped by this beautiful mathematical rule?